things I want to go over, okay, because we're simplifying rationals. We are still going to be factoring. Order is still super, super important. You always take out a GCF first. Okay, so let's put our phones up, headphones out of our ears. You can put them back in after the lesson. Okay, so two things I want you to know about fractions, because if you notice everything here is a fraction, it is okay to have a 0 on top. Oh, might help if I share my screen. So it's okay to have a 0 on top. It is not okay, so no 0 on bottom. Okay? It's okay to have a 0 on top. It is not okay to have a 0 on bottom. Okay, another reminder. Domain are your possible x values. Okay, now on this today, you'll see that some of this has K or A or C, so it's just your possible letter values, depending on whatever letter we're using today, because these aren't equations. They are all considered our domain. Now, I want you to realize that your domain is your possible x values, and you cannot have a 0 on bottom. So really, y'all, when we're looking for a domain, since we're not solving, technically your letter can be anything except what causes your denominator to equal 0, because that's not okay. So we are looking really for more what your letters can't be versus what they can be, okay? So let's look at the first one. So this is multiplication, and I want you to realize that you just multiply across for multiplication. So this is 7 times 63 AC cubed, and this is 9 times 35 A squared C. All I did was kind of reorganize it. Now, the reason I didn't actually multiply my numbers is because it's easier to simplify without doing that. Okay? Doesn't 7 go into 35? Isn't 35 just 7 times 5? And isn't 63 just 9 times, what is it, 7? So then technically, this 9 and this 9 cancel. 7 and 7 cancel. And we're left with 7 over 5. Now, where do I have more A's, on top or bottom? Bottom, so that's where A is going to stay. And now 2 minus, remember when there's no exponent, it's just 1. Because remember, with division, we subtract our exponents. So 2 minus 1 is 1, so I just have 1A on the bottom. Now, where do I have more C's? On top, so C is going to stay on top. I have 3 on top and 1 on bottom. What's 3 minus 1? So there's my final answer. Can that be simplified any further? No. So that's your answer. Now, one thing I should have mentioned at the beginning is you want to find your domain before you simplify. So before we started crossing things out here, we had an A and a C on the bottom. Okay? And it's all just multiplying. So when you're multiplying, what do you multiply by to create a 0? Don't you just multiply by 0? And it equals 0? There's no other way to multiply and get a 0. Okay, so knowing that, A cannot equal 0, because if A was 0 on the bottom, the whole denominator would have turned into 0. And C can also not be 0. Because again, if A or C were 0, the denominator would equal 0, and that's not okay. So let's look at example 2. What's wrong with the top of it? Who can tell me? Is the order right? No, we have to put it in order. Order still matters, just like GCF still matter. So we're going to flip it. And when I flip it, this is a positive 6 and a negative 3x. So I get negative k plus 6 over k squared minus 4. Okay, so now how can I factor the top and the bottom? Because they can both be factored. How would I factor the top? What should you always check for first? A GCF. Does the top have a GCF? Yeah, what is it? 3. What kind of 3? Remember, anytime the first term is negative, you take out a negative. So we're going to take out a negative 3. And when I take out a negative 3, divide by negative 3, divide by negative 3, I get k. And then 6 divided by negative 3 is negative 2. So that's my new numerator. Now, does the bottom have a GCF? No. So how can I factor the bottom? Can the bottom be factored? Think of all the ways we talked about yesterday. We talked about GCF, we talked about snowflake, we talked about difference of cubes, difference of squares, sum of cubes. It's the difference of squares. Isn't that a perfect square minus a perfect square? K squared is a perfect square because k times k is k squared. 4 is a perfect square because what? 2 times 2. So k squared minus 2 squared. And then remember, that's just a plus b, a minus b. So k plus 2, k minus 2. Now, can anything simplify or cancel here? What matches?
Top and the bottom.
What part of it?
K minus 2.
The k minus 2. Now, since there's a k on top and k is on bottom, could I cancel this k, and this k?
No, there's 3 of them.
You're exactly right. So you have to, but not even, almost. So you have to get rid of a whole factor at a time. The reason number 1 was different is because this was 7 times a times 63 times c cubed. Everything was being multiplied, right? There was no addition or subtraction, so anything was fair game to simplify. Now here you have factors that have addition and subtraction. When you have factors with addition and subtraction, you can't just cancel little pieces. You have to cancel the whole thing or it doesn't cancel at all, okay? So since the whole k minus 2 were the same, I was able to cancel it, okay? And now I'm left with negative 3 over k plus 2. Can anything from there simplify? No. So this is our final answer. And now our domain. Remember, you look before you canceled anything, okay? And I will tell you, it's easier to look at your factored domain than your original, because here you'd have to solve that for 0, but here it's a lot easier. I know that k cannot equal whatever makes either of these sets of parentheses 0. Well, what cancels a positive 2? A negative 2. And what cancels a negative 2? A positive 2. So k cannot equal negative 2 or positive 2. And I'll prove to you why. So if that didn't really make sense finding it like that, you can literally take each factor and set it equal to 0 and solve. And whatever it gives you is what k cannot be. So minus 2, k cannot be negative 2. Add 2, k cannot be positive 2. So however you want to think about it is how you'll find those. So let's look at number 3. Can anything factor further? Well, I mean, just like across the top and across the bottom. Can anything factor further? So no, nothing can. This is a perfect square and a perfect square, but it has a plus sign in the middle. Remember, for perfect squares, they have to be subtraction. Okay, so knowing that, let's find our domain before we keep going. I keep forgetting to do that. So we have A here and C here. So just looking at the first factor, we have A times 8 times A times C. So what can A and C not equal there? When there's no addition and subtraction, it's just 0. In this factor right here, there's no addition or subtraction, so they can't be 0. It's all multiplication. Now here, I have addition or subtraction. So what cancels an A minus 2, or negative 2? What cancels a negative 2? Positive 2. So A cannot be 2. Now I also have this A squared plus 4. So if I set that equal to 0, I want you to realize that I end up getting A squared equals negative 4. Can anything squared ever equal a negative? No, because think about it. A positive squared is a positive, and a negative squared is a positive. So technically, if you were to take the square root to cancel your squared, well, wouldn't that give me an imaginary number? Yeah, and imaginary numbers aren't real, so we don't have to worry about it. So this is your domain. A cannot be 0 and 2. C cannot equal 0. So now let's simplify. What can cancel right away? What matches? The A squared plus 4s. And you said the 2, so how can the 2 simplify or cancel? You're not wrong. Yeah, it simplifies to 1 over 4. The 2 over 8 simplifies to 1 over 4. Now I have A squared on top and A on bottom. How would that simplify? A on top. Now I have that C squared on bottom because there's no C right here on top. And I'm going to bring over my factors that didn't cancel. Can anything else right there cancel? Or simplify? Like, can this C cancel with this C? Or this A cancel with this A?
No, because they're in parentheses.
Because they're in parentheses. Remember how I talked about how it's different when they're multiplying, and when you have addition and subtraction, it has to be the whole thing or nothing? So this is C minus 3. This is just C squared. It's not the whole thing, so it can't cancel. When you have that plus or minus in parentheses, it has to be the same or nothing. Okay, so this is your simplified answer. Now, would it be okay if I didn't put the 1?
Yeah.
Yeah.
It would just be. This is very confusing.
It's a lot to think about. Okay, so let's look at number 4. What's wrong with the top right away?
Out of order.
Order. So remember, order matters. We need to write that. Order matters. Okay, order matters for sure. So I need to flip him. And I want you to realize this is a positive 3. So when I flip it, I get negative a to the 4 plus 3a cubed.
And then we have to do the times and subtract number.
So now we need to start with finding GCFs. Okay? Always look for GCFs first before you try to factor anything. So what's my GCF on top? A cubed, but remember when there's a negative at front, what do you have to take out? So we're going to take out a negative a cubed. Well, I took out that negative, and I took out 3a, so I have 1a left. I took out a negative. Well, I want you to realize this is the same thing as saying negative 1. 3 divided by negative 1 is negative 3, and I took out the a cubed, so that's what's left. Remember, it's the same thing as dividing. So if you need to negative 1a cubed, negative 1a cubed, and think about it that way, you can. Now, what's your GCF on the bottom?
2a, what did you say? Or, no, it's not.
Because there was a negative at the front. Anytime you have a negative at the front, you have to take the negative out.
Or 1, 3, 1, or 4.
Because you can't take 4 away from 3. But you can take 3 away from 4, right? Does that make sense? Because it has to be the same from both. And so, yes, I could take 4 here, but I can't take 4 here, therefore it's not a GCF.
So the smaller number?
Pretty much. Now, here, 2 does go into 6, so 2 is our number for GCF. And then I have a cubed and a squared, so we're going to take out an a squared because I can take 2 away from both of those. That leaves me with just a. Negative 6 divided by 2 is negative 3, and I took out that a squared. Now, before we cancel, I want to find my domain. And remember, I said it's easier to find when it's factored than when it's still together. So here it's factored, and we haven't canceled yet. What can this a not be? Remember, it's just multiplying, so it can't be 0. Now, what cancels a negative 3?
Positive 3.
A positive 3. So there's your domain. A cannot be 0 or 3 because that would cause our denominator to be 0, and that's not okay. It's not okay to have a 0 for your denominator. So now what can we cancel? You can cancel a squared here, so you can simplify, and you'll get negative 1 and 2 because that can't simplify. You have 3 a's on top and 2 on bottom, so you can get an a. What else cancels?
The whole big old a subtract 3.
So this is literally your answer, and if you want, you can rewrite it as just negative a over 2, or you could leave it as negative 1a over 2. They're both the same. Okay, so again, order matters. What's out of order? Jesse, what's out of order? Kirsten, what's out of order?
Oh, the next
This right here is out of order.
yeah,
Okay, so when we flip it, I want you to realize that's a positive 7. So we get negative x plus 7 over x plus 3, x minus 7. And now the reason order matters is because if you look at this right away, you might have thought that those two can cancel each other, but they can't because this is technically what that is. Okay, so now what should I always do if there's a negative at the front?
get rid of it.
Take it out. So when I take that out, I'm just going to put it in front of the 7. And I get, same thing as dividing by negative 1, so I get just x minus 7. And so what can cancel?
7 and x negative 7.
The x minus 7s. So my answer is negative 7 over x plus 3. But I still need to find my domain, and remember, it's easier to find before you canceled anything. So x cannot equal, well, what cancels a positive 3? And what cancels a negative 7? So remember, if you need to, you can set those equal to 0 and solve, and it'll give you negative 3 and positive 7. Well, if you put 0 there, doesn't that just equal 3? And if you put 0 here, doesn't that just equal negative 7? The only time you want to put 0 is when you have an A and a C as a factor without a plus or minus. So like this one didn't have a plus or minus on the denominator, this one didn't have one. So that's when, huh? I can't hear you. When, or even just one variable, but if it's outside by itself. These x's aren't by themselves. One has a plus 3 and one has a minus 7, and that's what makes like 0 fine. Okay? And you can even test it. If x was 0, you would get 0 plus 3 times 0 minus 7, which equals negative 21, so that's fine. Remember, the denominator can't be 0, but it can be negative 21. Okay, so the last one says to find the mistake, so I want you to look very carefully. And we're actually going to just kind of work it through because I do think we needed an example with snowflake and there's not one on there. So we're going to check it all. Right, Kirsten? So we're going to do the snowflake on the top. There is no GCF, so we're going to go straight into it. A is 2, B is 7, C is negative 4. So A times C on top, B on bottom, and then remember it's AX, well here we have M, so I'm using M. What multiplies to give you negative 8 but adds to give you 7? Huh? 8 and negative 1. Now, 2 over 1 does not simplify, so that's one of my factors, which they have. 2 over 8 does simplify to 1/4, so this becomes 1m plus 4, which it also has. Now, what's my GCF on the denominator? 5m, because 5 goes into 5 and 20, m goes into m and m squared. And that leaves me with m plus 4. So that's what they got. So the first step is 100% right. Now, what do you do from there? You cancel your m plus 4, which is right. Now, can it simplify any further? No, because this top has subtraction. And remember, when it has subtraction, it's all or nothing, right? And since it has that, can you just cross out the m's like they did? No, so this is where your mistake is. This is your final answer. Now, this is a good example to look at domain, though. Remember, before we cancel this here, 5 times what would equal 0? So m cannot equal 0. Because if you were to set that factor equal to 0 and solve, you would divide both sides by 5, and you would get m equals 0. Now, then you have the m plus 4. What cancels a plus 4? Negative 4. Okay, so you have 8 practice problems, and you only have the rest of today to finish them. I do have an answer key. It should be posted, and it's also right here in my classroom for those of you that are in person. It does not have domain on it because I think you need to practice that, and if you see it, you see it kind of thing. But I can check domain if you want me to. If you can't figure out why you got the wrong answer, let me know. We'll look at it together and we'll find your mistake, because that's truly what you learn from it. Kirsten, wake up or I'm going to make you stand up.